Okay, this is the Unit 3 exam review, and I will be working through select problems on it. So, in number 1, they're asking us to find the extrema of the function on the given closed interval. So, notice that we are given an interval and we're given a function. So, our goal here is to take the derivative. Then we need to set the derivative equal to 0 or find where the derivative does not exist. That results in what we call our critical values. Then you take those critical values and the endpoints of the interval, okay, and you plug those into the original equation to yield some outputs. These outputs are y values. So when they are asking for the extrema, that's the absolute max and the absolute min, they're asking that is a y value. So they're saying at what x value does the maximum y value occur or the minimum. So in this first example, the absolute maximum was 0 because if you'll notice all of these were negative, so the highest one of those would be 0. So the absolute max was at 0, 0, and the absolute minimum was going to be at the x value of 4 and the y value of negative 32. So very similarly, we can do that with some trig as well. So for this first one, I'm just going to take the derivative and set it equal to 0. So here, the derivative of sine is cos, so this is just going to be 2 cosine of x minus 1, okay? And I need to set that equal to 0 or find where it doesn't exist. I do not need to worry about where that doesn't exist because cosines, it's not divided by 0 or anything like that. So basically I set that equal to 0. So I end up with cosine of x equals positive 1/2. And what we're saying there is where on your unit circle does cosine equal 1/2? Well, cosine's positive in quadrants 1 and 4, and that's going to be my pi over 3's. So cosine is 1/2 at pi over 3, and also positive 1/2 at 5 pi over 3 down in quadrant 4. And just like before, we're going to take the critical values there, and we're going to plug them into the original. And also we need to make sure that we plug in our endpoints. So we just take all these. Sometimes I do my endpoints first just so that I don't forget them. But I'm doing them second here. Okay, so go ahead and plug those in. And remember, when you're plugging these in, you're going to be plugging them into the original. And when I plug in 0, I get 0. When you plug in 2 pi, I get negative 2 pi. When I plug in 5 pi over 3, ooh, that's going to be a nasty one. That'll be like negative radical 3 minus 5 pi over 3. Yuck. And then if I plug in pi over 3, that'll be radical 3 minus pi over 3. Okay? So, you can kind of get an idea of what those are. If you need to use your calculator to kind of get an idea of what those are, you can. But the maximum is actually going to be this right here, because it'll still be positive. Like, obviously, and then the minimum, if we have this, a negative minus another, 15 over 3 minus 5, that'll actually be our minimum. So we can say that there is an absolute max, okay, at pi over 3, comma, radical 3 minus pi over 3, and I'm not even going to change that to a decimal, and at 5 pi over 3, and the y value would be negative radical 3 minus 5 pi over 3. Okay, and that's how you do that. Now, in example number 2, they're asking to identify the open intervals on which the function is increasing, decreasing, okay? So that's classic first derivative test, and what we want to do here is use the first derivative test, and then we're going to set the derivative equal to 0, find where the derivative does not exist, and then we'll have to do a sign chart. Remember, a sign chart is going to be able to tell you when you plug in, you care if the derivative is positive or negative, and then that's going to tell you the behavior about the original function. So in this example, I'm going to take the derivative. Okay, and this is going to be a chain rule, so you bring the 3 out, you recopy this, you decrease the exponent by 1, and then you multiply by the derivative of the inside. The derivative of the inside here is just a 1 though, so that makes it a little bit easier. And I set this thing equal to 0. So if I set that equal to 0, okay, you could divide both sides by 3, and you'll just get this. Then you square root both sides, and you just get this, because the square root of 0 is 0. So after all that work, you end up with x equals a negative 1. Okay? So that negative 1, again, is called your critical value or your critical number. And from there, we are going to use a sign chart and put it on the sign chart. Okay, so I only have one critical value, so I'm just going to stick it right there. And remember, I plug into the derivative, and I only care if the derivative is positive or negative, and that's going to tell me the behavior of the function. So when I plug in a number to the left of negative 1, so I don't know, like a negative 2, into the derivative of negative 2 plus 1 is negative 1, squared is a positive 1, times 3 is still positive, so I get a positive over here. And then I plug in a number to the right of it, so 0 is probably the easiest thing. If I plug in a 0 there, square it, that's positive times a positive, so I still get a positive over here. And again, it's not uncommon for that to happen. It usually alternates, but it doesn't have to. So in this case, that tells me that the original function is increasing the entire time. If you kind of think back to what your parent cubic graph looks like, right, that makes sense. This is just your cubic shifted to the left by 1, so you should even be able to kind of get that it is increasing from left to right the entire time. So this is increasing over the interval, right, so f of x is increasing on the interval negative infinity to negative 1, union negative 1 to infinity. Alright, and that is the end of page 1. Okay, for number 4, we are asked to find the critical numbers, and then we're also asked to find where it's increasing or decreasing, and also finding the extrema. So the first thing you're going to want to do here to find the critical numbers is you're going to take the derivative and set it equal to 0. So here, the derivative, h prime of t, so 4 times 1/4 is 1, so that'll just be t cubed minus 8. And then you set that derivative equal to 0, so that ends up with t cubed equals 8, and that tells me that t equals 2. So then that brings me right down to where it says find the intervals where it's increasing or decreasing. So that's asking me to do a sign chart. So I take that critical value of 2, I put it on the sign chart, and I'm plugging into the derivative. So when I take 2 and I plug it into the derivative, that's going to be, take a number to the left of 2, so like a 1. 1 cubed is 1 minus 8, that's going to be a big old negative number there. Then I plug in a number to the right of 2 on the sign chart, so like a 3. 3 cubed is 27 minus 8, that's still going to be positive. What does that tell me about the original h? It tells me that it was decreasing until it hit 2, and then it started increasing. So I can say that h of t is increasing on the interval 2 to infinity, and is decreasing on the interval negative infinity to 2. To find all the extrema, express your answer as an ordered pair. So this is just kind of breaking up all the steps here. So to find the extrema, that's finding a max or min. So looking at this sign chart, if you are decreasing and then increasing, well, that tells you here that this 2 is a minimum. Okay, if you were increasing then decreasing, you'd get a max, but this one's a minimum. That's the only critical value I have, so express it as an ordered pair. Oh, so I need to say that there is a relative minimum at, and it's 2 comma, it wants it as a point, so that means I need to go and get that other value. Well, how do you get that? You're going to take this 2, and you're going to plug it back into the original, okay? So when you plug that 2 into the original, 2 to the 4th power is 16 times 1/4 is going to be 4. So I've got 4 minus 16 there, because if I plug in a 2 right here, so that'll give me a negative 12 as my y value there. And I'll just make a note here that there is no relative maximum on this problem. Alright, perfect, and that's how you do number 4. Okay, for number 5, we have f of x equals cosine of x minus sine x, and we're basically just trying to do the same thing, but this one has trig. So again, to find the critical values, your goal is to take the derivative, set it equal to 0, right? And then we're going to use a sign chart to figure out if they are maxes or mins. So here, the derivative of cosine is negative sine x. The derivative of negative sine is going to be negative cos. So I take that and I set it equal to 0. And this is one where people get a little bit confused, because when they set it equal to 0, they're like, well, I can move one of them over, but where in the world does cosine equal negative sine, or where does negative sine equal cosine? So for that, I'd basically like to kind of point out this unit circle here, and we're looking for where cosine and sine are the same. Well, they're the same at all your pi over 4s, right? They're both radical 2 over 2, but I want to know where one of them is the opposite of the other. So that would only be, see how this one's negative and this one's positive, and then down here this one's positive and this one's negative? So those are actually the angle measures that I want to work with for here. So this is going to give me the x value of 3 pi over 4, and then down in quadrant 4 it was 7 pi over 4. So those are your critical values. And then to figure out where the original is increasing or decreasing, I'm going to, notice that it's a trig function, so I was given an interval. So when I do my sign chart, instead of having like the arrows, I'm actually going to have them stopped there, and I'm going to go from 0 to 2 pi because that was my given interval. And then I put these critical values on there, and they go on there like this. And again, I'm plugging into the derivative, so I indicate that by putting the derivative up there, and it's going to tell me the behavior about f of x. So to do this, I plug in a number between 0 and 3 pi over 4. So an example might be something like pi over 4, right? So when you plug in pi over 4 into the derivative, right? So if you plug in pi over 4 into the derivative there, the sine, but you're going to have to negate it, and then you have minus the cosine of pi over 4, which is radical 2 over 2, negative radical 2 over 2. So this one's actually going to be negative there. When you plug in something between, a good example of something between there would be something like pi. So when you plug in a pi, the sine of pi is 0, so negative 0, and then the cosine there is a negative 1, so it'll be minus a negative turns to a positive there. And then you could plug in something over here, I don't know, 11 pi over 6 would work. Anything to the right there. And that's going to be negative when you plug in there. So that tells me that the original is decreasing, then increasing, then decreasing. So if you're decreasing and then increasing, that means that this guy here is going to be a minimum. And if you're increasing then decreasing, that means this one here is going to be a maximum. Sorry, that A got a little messed up there. So that's a maximum there. And it says identify the extrema, and what they want it as an ordered pair. So I can say that I have a relative max at, it'll be 7 pi over 4 comma something. How do you get that something? You actually have to go back and plug this 7 pi over 4 into the original. So when you plug that 7 pi over 4 into the original, you get radical 2. And then you have a relative minimum at 3 pi over 4, and you take that 3 pi over 4, plug it back into the original, and when you do that, you'll get a negative radical 2. Oh, up here I forgot to actually make my conclusion. So I can say here that f is increasing on the interval 0 to 3 pi over 4, and then, oh, whoops, that's decreasing. It's decreasing on the interval 0 to 3 pi over 4, and then union, and then, oh, am I going to be able to fit it in there? 7 pi over 4 to 2 pi. And I could say that it is increasing on the interval 3 pi over 4 all the way to 7 pi over 4. Okay, so there's my conclusion for number 5. Okay, number 6 we're going to go through really quickly. You're going to take the derivative, and then you're going to actually take the second derivative, because for the points of inflection, it's not asking me to conclude anything about increasing or decreasing. So I'm going to take the first derivative, and that's going to be 3 minus 15x squared. And then I go straight to the second derivative, which is just going to be a negative 30x. Well, negative 30x, I set that equal to 0, and you end up with x equals 0, right? So that x equals 0 is a possible point of inflection, so I'm going to do my sign chart real quick. Okay, so when you put 0 on your sign chart there, again, you're plugging into the derivative. You get a positive for a number to the left of 0, a negative for a number to the right of 0, and these are your final conclusions.